In this video, I wanted to discuss rotational kinetic energy. Be sure to watch my video on translational kinetic energy if you haven't already. If you have watched that video, you know that the translational kinetic energy of an object is equal to 1/2 multiplied by the mass of the object multiplied by the velocity squared. For rotational kinetic energy, we'll need to use a different but somewhat similar formula. In most of my rotational motion videos, I've discussed how the formulas are really just the rotational equivalents of the translational motion formulas that you already know. The same thing actually holds true for rotational kinetic energy. We just need to replace mass and velocity with their rotational equivalents. For that reason, rotational kinetic energy can be written as 1/2 multiplied by the moment of inertia multiplied by the angular velocity squared. In my moment of inertia video, I discussed how moment of inertia is really just the angular equivalent of mass. And in my rotational motion video, I showed how angular velocity is really just the angular equivalent of linear velocity. It's important to understand that this rotational kinetic energy formula is really just summing the translational kinetic energies of every particle in a solid object. The units will be in joules just like for any other energy quantity. We can write that the kinetic energy of a solid rotating object is equal to the sum of all of the translational kinetic energies of the particles in that object. From rotational motion, we know that the linear velocity of any particle in a rotating solid object is equal to the distance from the axis of rotation multiplied by the angular velocity of that object. We can then say that the total kinetic energy is equal to the sum of 1/2 multiplied by the mass of each particle multiplied by the distance from the center of rotation squared for each particle multiplied by the angular velocity squared for each particle. We can factor out the 1/2 and also the angular velocity squared since we know that it'll be the same for every particle. And the sum of the mass times the distance from the center of rotation squared for every particle is just simply the moment of inertia for the object. Rewriting this, we see that it gives us the rotational kinetic energy formula that I mentioned at the beginning of this video. This rotational kinetic energy formula represents the total kinetic energy for an object that's only undergoing rotational motion. For an object that's undergoing both rotational and translational motion, the following formula must be used. This is just simply the rotational kinetic energy of that object added to the translational kinetic energy of that object. For the translational kinetic energy, the linear velocity of the center of mass of the object must be used. And for the rotational kinetic energy, you'll need to use the moment of inertia taken about an axis through the object's center of mass. If an object is not rotating, its angular velocity will be 0, causing the second term of this equation to disappear. If an object is only rotating and has no translational motion, its linear velocity will be 0, causing the first term of this equation to disappear. It's important to understand that rotational kinetic energy can be used just like any other energy quantity. You can use this in a conservation of energy equation with translational kinetic energy and gravitational potential energy, or with any other type of energy present in a problem. I hope that this video was helpful in explaining what exactly rotational kinetic energy is. If you still have any questions, feel free to comment below, and I'll do my best to answer them. If this video was helpful, please give it a like and consider subscribing to the channel for more fast physics videos. Thanks for watching.